Hey y'all, what's up? How you? Alright, so the math mafia, no, like, you can't have a mafia with just one person, can you? I mean, it's like Christ and I, but he's like always God. I'm not. Okay, so, hold on. Hey y'all, what's up? Yeah, so the math bandit back at it again. Okay, yeah, so I hope you guys have been well, and I hope Christ is with you in all that you do. I had a first recording of this that was really, really fun. So I might post it as an outtake, even though I've never done that, because it's really fun. But yeah, I realized that like I left out a content somewhere that, yeah, gave me the wrong result, and so I'm re-recording a second time. So I have a series of videos called limit proofs, and they prove some really, really useful, important limits that we frequently use, like the e to the h minus 1 over h, right? And another one that I do in my limit proofs is cosx minus 1 over x. This one is very similar to that one, but it's not that one. So our solution and our approach and everything is going to be quite different to this one, right? And this one is limit as x goes to 0. It is 1 minus cos x over x squared. And the one I mentioned that is very similar to this one is cos x minus 1 over x instead of over x squared, and it's the additive inverse of what I have in the numerator in that other video. Okay, enough said, right? Okay, so how do we do this? Well, okay, so recall that of 3 different formulae for cosine 2x. One of them said cosine 2x equals 1 minus 2 sine squared x. It's that 2 that I left out in the first recording of this, and hence why I have to record it a second time. And sine squared x, we know we need sine x whole squared, right? Okay. All right, now notice that first, if I get rid of this 2 right here, right, then I'd have to write sine x over 2 in the argument of sine right there, right? Okay. Second is I could rearrange this equation so that I have 2 and then times sine of x over 2 whole squared is equal to 1 minus cos x, right? Okay, now check this out, y'all. Why did I care to do all this? Because right there, right? So that numerator, 1 minus cos x, we can replace with this left-hand side, right? Okay. So that means that our limit question is the same as lim as x goes to 0. So at the last private school where I taught, they used to have us like swap out old markers for new ones. They wouldn't just give it to you, you have to swap them out. Now I see why, because like, you know, some scatterbrain people or like some math people like me like forget where things are and like they dry up, or if they're plugged, you don't care. Okay, I don't either actually. So limit is x goes to 0 of and it's 2 sine of x over 2 squared over x squared, right? All I have done in this step is I have replaced 1 minus cosine x right there with this here, which we have found out it is through our work right there. Okay, now there are some conveniences here, but before the conveniences, for reasons you're about to see, I'm going to do the following, which is I'm going to divide by 4 right here, and therefore I'm dividing the numerator by 4, and therefore I have to divide the denominator also by 4. And you'll see why I had to do that in a second, yeah? Okay, I did it much cleverly, much more cleverer in the first recording of this. But like, yeah, it is what it is, c'est la vie, right? And so I have to record it second time, so like, I'm gonna do it differently this time, although a lot less clever. Okay, so then here. So first, notice I have a 2 over 4 right there. That's a constant. I keeps it right there. And that's just a 1/2, right? And now I have sine of x over 2 over, and then I could write x over 2 right here, all to the second power. Notice that this is exactly the same as what I had. First, well, the sine x over 2 squared, that's retained. This 2 over 4 is right there, and x over x squared over 4 is x over 2 squared, right? Okay, and this is where I reveal why we want to divide by 4 right there and right there, right? It's because we want to use that, like, you know, super famous, most famous limit statement that says lim is theta goes to 0 of sine of theta over theta is equal to 1. I have a couple of different proofs of why this has got to be true, so check those out. But this is true, right? And we want to use it in this part. Well, first, notice that we have the limit law that allows us to put this limit and write it right here. So limit is x goes to 0, so I can put it right there. And second is, well, having divided by 4 there and there, like kind of predicting the future, right? Like now we can say that this is theta, because what has to happen in order for us to use this limit is like this argument right there, whatever theta is, it's got to be the same as what's in the denominator. And that's why we want to divide by 4 in that part, because we have x over 2 in the argument of sine, and we have x over 2 here. Theta over theta, and yes, this says x goes to 0, but as x goes to 0, theta goes to 0. That is to say, if I have theta equals x over 2, as x goes to 0, theta goes to 0, right? So, okay, you know, I want to take care of you with some important details and stuff, right? And so this is 1/2, right? So I write 1/2, and then I've got 1 squared, because this limit says, ooh, my bad. Okay, that's not the right lid, and this is not the wrong lid. This, never get it right. So this says 1, right? So this is 1 in here. So I've got 1/2. Other than, you know, the substitution statement, 1/2, that's that 1/2 times 1 squared, and so that's 1/2. Yeah? Okay, I'm done.